So we have scheduled it to be in two parts. The first part will be, we'll have a welcome speech from the European Commission, from Rafał Stanecki, who is a policy officer from the Directorate General of Mobility and Transport, and as well from Mr. Sergio Krieger, who's project manager at the European Commission INEA, that's the Innovation and Networks Executive Agency. Later, we'll have a keynote speech from Dr. Jurgen Krieger, who is the director of Bridges and Structural Technology at the Federal Highway Research Institute. He's also the coordinator of the strategic theme for resilient infrastructure at PIAC, that's the World Road Association. We'll then have 4 presentations from the projects. Safeway, that's from Ms. Belen Riverio. She's an associate professor at the University of Vigo. Iñaki Beltran will talk about the FORESEE project. Iñaki is a project manager at Tecnalia in Spain. The RESIST project will be presented by Costas Buklas, who is a scientific project manager at the Institute of Communication and Computer Systems. And last but not the least, we will have a presentation of the Panoptis project from Philipp Krabosinski, is a program manager at Airbus Defense and Space. So that will be the first part, and the second part will have a panel discussion. I will go to that later. But without further ado, I will kindly ask our colleagues from the European Commission, Rafał Stanecki and Mr. Sergio Krieger, for their opening speech. Over to you, please.
Thank you. Can you hear me?
Yes, we can.
Okay. Thank you very much, dear dear participants. Thank you for the invitation to today's workshop on increasing the resilience of the European transport infrastructure. The aim of the European Union's transport policy is to promote mobility that is efficient, safe, secure, and environmentally friendly. So we have these 4 pillars, but these objectives are inherently linked to the existence of the resilient transport infrastructure, as it is a backbone of transport and mobility in the EU. Let me bring you some figures to realize the importance of transport for the economy of the EU, not only as an individual sector, but as a foundation for economic growth across sectors. So there are 1.2 million enterprises active in transport sector, 11.5 million persons are employed in transport and storage, and the transport creates 66.4 billion euros in gross value added. We should not forget about incalculable socially important aspects of transport for everyday commuting and leisure travel, connecting families and friends, maybe a bit less during COVID, and also contributing to regional cohesion. I mentioned all this to emphasize the importance of transport and what you're working on. To fight the climate change, the EU has committed to become a climate neutral economy by 2050, with reductions of 90% of emissions coming from transport. But threats to the infrastructure due to extreme weather conditions and climate change will not stop in the coming years. In addition, apart climate threats, solutions are needed in case of serious disruptions due to terrorist attacks or unfortunately crumbling infrastructure. That would be all for very fast and introduction from my side, and I would give floor to Sergio, who will focus on the 4 projects presented today. Thank you.
Over to you, Sergio. Sergio, we can't hear you. You're muted.
Okay, now it should work. Can you hear me?
Yes, yes, yes.
Okay, thank you. Thank you, Rafael, for the introduction, and Wally and the organizers of the event for the invitation. Building on the introduction by Rafael, the topic that is common to all the 4 projects was already published in 2015 in October. So it's a long time since the publication of the topic, submission of proposals. They are dated from October 2017. But what is clear is that this policy approach at that moment was correct, and the facts over the last few years have confirmed that the topic was meaningful. For example, the challenge of facing climate disruptions due to extreme weather events. These are more and more common, unfortunately. So it makes sense really to make the infrastructure stronger and more resilient. Not only about climate change, but also man-made events. We are talking about the strikes, terrorist attacks, but any other type of man actions that can disturb, let's say, the normal operation of transport system. This is critical and has become critical over the last few years. So the challenge was fully correct and has been confirmed. But also the scope. The topic talk about innovative technologies to face those problems. For example, identification of risk factors, mapping of extreme weather conditions, climate risk hotspots, using remote technologies, for example, drone or also satellite images. The topic also talk about new materials, construction and maintenance techniques that can improve the resilience of existing infrastructures, structural health monitoring, and improvement of the links between different transport modes, so that in case of disruptions, the modal transfer can happen smooth and straightforward. The social dimension was also mentioned there, and all these aspects have become relevant and have been confirmed with the different technologies in the last few years. Some of them are already familiar, are already in our daily life. For example, drones or virtual reality, digitalization. We don't need to convince anybody that these are useful tools to manage the infrastructure in a more efficient way and to be ready to face disruptive events. So that was a good starting point. All the projects based on individual technologies with a common history. Let's say the fact that the projects address the same topic doesn't mean that they are overlapping. They are quite complementary indeed, because they use different technologies in different combinations, but at the end, all of them work as a system in every of the 4 projects. And the phase in which the project have started this year is the second half of the projects. At this moment, the individual technologies are already developed. The in-lab testing in some cases are already done. The integration has already started, and it is the moment to put everything together in real demonstration pilots. To this end, the project have selected very smartly the 10T corridors as the major infrastructure for demonstration of these technologies. The project outcomes will be there very soon, but in some cases they will not be ready for the market uptake. They will need more development, more testing. But you are now starting an excellent moment in which you have already some results. You are going to go with your technologies to real scenarios where you can get more visibility through press, media, through all your dissemination means. And this is key factor to convince potential interest parties to continue the investment, to continue the development of this project, putting more funds. For example, if we talk about industry stakeholders that are able to absorb, to take these results and put them to the market level, or also you will be interested to attract the interest of infrastructure owners. They at the end will be the end users of the technologies, but they will also offer opportunities for deployment, for more testing, and in some cases even for funding innovations through public procurement. So it's the moment really to work hard on the demonstration in one side, but also in the dissemination in parallel. At the end of the project, what we want to see is that the main stakeholders are convinced that these projects make sense, that the technologies have possibility to be implemented, and at the end we achieve the impact that were expected in the topic. Closing my remarks about dissemination, I would like to remark that there is a special session about resilient infrastructures in the Road Transport Research 2020. This will happen on the 30th of November, and the registrations are open. I hope the organizer of the event can share the link to this event, in which we will be able to see again the 4 projects together, and everybody that is interested to participate or to be in the question and answer session will be more than welcome. Thank you.
Thank you very much, Sergio. Thank you very much, Rafa, for the presentations. Indeed, we will share the link to register for the upcoming EC ETRAC EGFIA conference, which take place at the end of this year. Thank you very much. We'll go to the keynote speech.
I have one short information on Horizon Europe, because sorry, I think it's important to mention that there will be a follow-up in the research programs. The Horizon Europe is the next research innovation program for the years 21-27. It's still being negotiated, but I can bring you some information. Its the budget is 80 billion euros. 7 billion have been earmarked for mobility and transport topics, and in the first work program we expect a topic on resilient transport in infrastructure, with the objective to increase TRL levels and pilot demonstration in operational environment. So there will be opportunities for further contribute to increasing resilience of transport infrastructure. Thank you, and sorry for this interruption.
Good. Thank you very much, Rafa. Thank you for this valuable information. We go to the keynote speech by Dr. Jurgen Krieger. I've made you the presenter.
Okay, thank you very much. I hope everybody can see my screen now and can hear me, can also hear me. Good morning again. My name is Jurgen Krieger. I'm working for BAST, Federal Highway Research Institute, but Adebola has already introduced me. So I have put together a couple of slides on resilience, where we are and where we should go. Before I start, I would like to thank the organizers for this invitation and giving me the opportunity to present today. So this is my first slide. Hope you can see it. I would like to talk a little bit about the bigger picture of resilience. So what does it mean? What is the context? Really short. So for this, of course, you might know, these are the Sustainable Development Goals of the United Nations. And one of the goals, goal number 9 here, is about industry, innovation, and infrastructure. And when we look at this goal a little bit in more detail, we see a target. So each goal has one or more targets. And what we find here has already been mentioned by the speaker before. So develop quality, reliable, sustainable, and resilient infrastructure. So we now have an idea where resilience is positioned. What we also have to say that, and this slide shows a little bit about the position. So resilience contributes to sustainability, contributes to future generations. resilience, a part of resilience is risk. Very often I hear risk and resilience is the same. No, in fact, it's not. Risk is an integral part of resilience, but resilience and risk, or resilience management and risk management are, it's not the same thing. So with risk, we work with known knowns, maybe a little bit, but this is also difficult within traditional risk analysis with known unknowns. In resilience, we can work with unforeseen events like black swans, threat, where we have somebody, or complex system risks. So this is more or less the position of resilience within sustainability. I wanted to show. So what is resilience then? If you Google it, you will find hundreds, maybe thousands of definitions. 4 of them are mentioned here. You see that some terms are really in common here. So this is prepare is mentioned, absorb, recover is mentioned, adapt is mentioned. All these definitions go in the same direction. They are not identical. So my favorite is this one, but your favorite might be another one. So I think that we can agree that preparation, adaptation, withstand, response, and recover are elements, important elements of resilience. So very often you see something like this. So this is the performance, system performance over time. So you have an incident at a certain time shown here. And what is resilience? So resilience starts well before the event. You can prepare, you can plan, you can protect your structures or your assets, respond, recover, adapt, prepare, plan. This is why you very often see something like a resilience cycle. So all of this is resilience. All these elements are elements of resilience. Quantification, very often you use these areas to quantify resilience. So I would not like to go into detail here. So already mentioned before, what are the threats? What could be the events? So this could be, first of all, natural hazards, earthquakes, landslides, and so on and so on. Storms, tsunamis, but also other hazards, man-made events, terrorist attacks, cyber attacks, more and more important, I think, also for our infrastructure when we move to smart roads and smart infrastructure. So it's important to know that resilience is or should be an all-hazard approach. So it's not for one specific hazard. So where we are with this topic of resilience. So Advol already mentioned that I have a function in FERL, in PIAC, World Road Association. This is the strategic plan, and what you can see here, you can download this plan on the PIAC website. So resilience of road infrastructure is one of the cross-cutting issues within this strategic plan of PIAC for this cycle. So these are the TCs. You know that PIAC is not a research organization. PIAC works more on case studies, on good practices, best practices. We have one strategic theme, which is called Resilient Infrastructure with pavements, bridges, earthworks, tunnels. And we have TC14, Resilience of Road Networks. And of course, we have a TC on asset management. And all these TCs have topics, have at least one topic about resilience within their terms of reference for this cycle. So again, PIAC is not research. Therefore it's more where we are. So PIAC collects best practices based on the analysis of case studies. So this is what PIAC does and PIAC what we'll do. When we look at technology readiness level, we are more in PIAC, we are more here, level 8, level 9. So we are collecting applications, good examples during this cycle. So a little bit different, of course, like mentioned, the project FORESEE. So I have just copied and pasted something from the internet sites, websites of these projects. So FORESEE looks at methodologies, awareness, but also on specific measures for specific elements of our infrastructure. And what I like to see, what I love to see here, we will have probably guidelines at the end of the project, which makes the implementation much more simple. So resist, robotic inspection, predictive analytics, restoration. So this is more come back to normal operation, and communication, which is absolutely necessary in emergency situations. SAFEWAY works on 3 elements here: preparation, response and recovery, and mitigation. So more or less the most of the elements of the resilience. And Panoptis looks at climate change scenarios and will develop or aims at developing integrated tools, which is important. So I think we can somehow answer this question. So looking at PIAC, we will collect good practices and analyze case studies, good examples. So this is important. So we will see how owners and operators work with resilience. And of course, from these 4 projects, I expect a significant step forward. Of course, this needs, like already mentioned, this needs the project results need implementation. So this was the first part of my presentation. The other question, so where should we be? And in my opinion, where should we go with resilience? So this is also important. So this is system of systems approaches. So at this moment, we look at transportation, we look at bridges, we look at tunnels, but we do not look so much on a systems of systems approach. This is taken from a research publication, this picture here. So this is, of course, really simplified, but there are other sectors. This is transportation, oil, electric, telecom, water, gas, natural gas, and everything is connected. So I think we should move from this specific resilience, which we are doing now, to a more general resilience. So where we can take into account that each subsystem interacts with others and that we have top-down approaches and bottom-up approaches, and that these questions are really multidimensional. These are really complex analyses and complex models, of course, but I think when we look at especially black swans or pandemics, we need this kind of approach in the future. So this brings me to my last slide. What is needed? What do owners and operators of transport networks really need? So we need design guidelines, standards that take into account resilience. We need to integrate or find a way to integrate resilience into project development. And of course, we need to fully integrate resilience management into our existing asset management systems. Then we have to look at interdependencies with other infrastructure sectors. And of course, we need methodologies and models for analyzing this and look at what-if scenarios and unknown unknowns. Cascading effects are important to consider. For, of course, supply chains, contingency management are important aspects here. Then, of course, during an event, the emergency management training for transportation agencies is important on all levels, not only the workforces, but also the management. And something which is done, of course, from time to time, but I think it should be done more regularly. So this is something like post-disaster engineering. You could also say forensic engineering. And of course, I don't know, maybe the most important part here, what is the economic benefits from investments in resilient transportation assets? So these are just a few points that came to my mind when I thought about where should we go and where should we be. So this was my really short presentation, and thank you very much for your attention.
Thank you very much, Professor Krieger. Thank you for this in-depth presentation, looking at where we are and where we should be. I'm sure we'll build on this as we go along in today's conference. I would not like to ask Ms. Belen Rivero from University of Vigo to give us her presentation about the Safeway project. Please, the floor is yours.
Okay, thank you, Adewale. First of all, good morning to everyone. My name is Belen Ribeiro, and I'm an associate professor at the University of Vigo in Spain. And today I'm going to present Safeway project in my role of project coordinator. And before going into details of our project, I would like to introduce you to the Safeway Consortium, which is composed of 14 partners that you can see in the bottom part of the slide, representing 8 countries in Europe, and our project has a total duration of 3 years and a half, with an overall budget of 4.5 million euro. Similar to the projects that are being presented today, Safeway aims to improve the resilience of the European transportation networks by addressing the 3 main phases of the crisis management, and by providing or proposing new technologies and methods to increase the resilience. I will be supported by this graph, this typical graph that we use for the quantification or the evaluation of resilience when an external threat happens, in order to just summarize which are the main contributions of a Safeway. For example, if we think of the preparation stage, Safeway is developing methods in order to assess or to identify which are the hotspots of our networks, being sourced by external databases or open access maps and databases from other European projects, in that way valorizing the investments made by the European Commission in other similar or complementary projects. We are also using remote sensing as an essential technology for the condition monitoring of infrastructure. This is, or the aim of using these new sources of data is to be the input to new methods to quantify the consequences of the events that may happen due to the external hazards, and also to be prepared with alternative routes, or to in some way to mitigate the impact of those external threats. In terms of response during the event, Safeway is also proposing new technologies or innovative concepts that involve using the connected vehicle data, and also exploiting social media as a means of optimally communicate with all the agents involved in the chain of transportation. This is operators and also end users. And not less important is to mention that Safeway is also developing research relating to long-term effect of resilience. In this sense, it is needed to mention that we are, or some partners of our consortium are developing or working in the construction sector and developing new construction systems and responding to the adaptation needs due to external or natural hazards, but also including smart materials in the infrastructures in order to have a stronger assets. So basically the idea of Safeway is to combine all those new components or those innovations through an IT platform whose main capabilities refer to the capacity to ingest all these new sources of data, to integrate those new methods for data analysis, and finally to provide tools for decision making. And in this sense, it is worth mentioning that maybe one of the key components of the IT platform is an enhanced decision support system, which is being supported by risk-based predictive models, whose final aim is to minimize that area of the curve that we were looking at before. Not less important is to mention that the platform is not only recruiting information for decision making, but also acts as a point of exchange of information with all the agents involved in the use of the transportation network. This is the managers and operators, but also the end users like passengers or even drivers, okay, by providing real-time communication and also recommendation on which is the optimal evacuation route. Just to show you quickly some results that have been already achieved in the project. One of the most relevant ones related to the quantitative risk assessment of damage due to natural and human-made hazards. This is a framework that can be also applied at the European scale by developing maps or hotspots, points of the transportation network, where can be the critical points of the network in the event of extreme hazard. Also methodologies for the assessment of the exposure of our networks to different types of hazards have been developed based on GIS technology. And as you can see in the slide, there are some maps that we can create to illustrate a prognosis on the vulnerability of the European transport networks to future events. The quantitative risk assessment approach is not only focused at a European scale, but also at a asset level. And in this regard, the methodologies that are being implemented in the project also consider the vulnerability analysis in terms of structural and functional vulnerability. Also methodologies to quantify the impact at different levels in case of failure of these assets. And it is also worth mentioning that Safeway is developing research regarding improvement of prediction for the deterioration processes of our structures, and also the update of the reliability index due to these external agents. In that sense, this is connected to the monitoring of assets or the condition assessment of assets by using new monitoring technologies. Particularly, Safeway proposes to use a multi-scale infrastructure monitoring system based on using both satellite imagery in order to compute displacement by using radar data of the assets and the surroundings, but also be complemented by terrestrial remote sensing technologies as LiDAR-based mobile mapping systems, which are able to provide very accurate 3D models of the infrastructure, providing high accuracy in the geometry, but also being a means to identify automatically damages or a pathological condition, which at the end are used to create updated BIM models of infrastructures, in which Safeway is also adopting the latest developments of open standards. Another sources of monitoring is related to crowdsourcing. As I mentioned before, Safeway is recruiting information in real time from connected vehicles, but also exploiting social media data in order to complement the monitoring or the real-time performance of the infrastructure. But at the same time, this new concept involves communication in both directions, okay? Recruiting information from the users, but also being a channel to provide which is the most efficient or the optimal evacuation route in case of a disruption in the transport network. In this regard, Safeway is already being implemented. All those technologies are being implemented in the alpha version of the Safeway IT platform. You can see here just a screenshot of the platform. But I would like to say that not only IT research is the focus of Safeway, but also research is being done in terms of actions in the long-term scale, okay? By reconsidering emergency planning, by including the new concepts or the new technologies that have been already mentioned, but also in a different level, research is being done in order to provide more strong construction systems, and also including some new sensors like fiber optics or new materials like shape memory steels. Finally, I would like to finish my presentation by summarizing which are the 4 operational environments where Safeway is to be demonstrated, which are linked to the 10T core network by having pilots in 4 countries, in Portugal, Spain, the UK, and the Netherlands, in which different scenarios are to be evaluated. Most importantly, flooding event, as is probably the greatest event that affects the whole Europe, but also wildfires in Portugal, and also some test beds for monitoring technologies in the UK and connected vehicle infrastructure in the Netherlands, and new construction systems in Spain. So with this slide, I finish my presentation. Thank you very much for your attention. And if you have any questions, I will be very happy to answer at the end of this session, or just feel free to contact us through our social network. Thank you very much.
Thank you, Belen, for this very interesting project, a very interesting presentation as well. Before we go to the next presenter, I would just like to remind us that if you have any comments or any questions, you can use the chat function, and at the appropriate time, your questions will be addressed. The next presenter is Iñaki Beltran from Technalia, and he'll be talking about the FORESEE project. Iñaki, the floor is yours.
Thank you. Well, I think that you can see my screen. Am I correct?
Yes.
Okay. So, thank you. Thank you, Wally. So, first of all, thank you all for being here today. I hope that the presentation are going to be interesting for you. I also would like to thank Philipp for the effort coordinating this joint workshop, and also the previous speakers. I would like to highlight to Sergio, Rafael, and Jurgen, because they have summarized and highlighted quite important topics and issues that we are facing in these 4 projects. So I would like to highlight that. I'm here as being presented, Iñaki Beltran. I come from the Technalia Research and Innovation Foundation, and I'm going to talk about the FORESEE project, which aims to develop a set of tools and other outputs that will be finally integrated in one single toolkit that will be used to mitigate the impacts of this disruptive event. Well, natural has been explained by Jurgen, I think, and man-made events. So just a quick presentation about Technalia, which is a benchmark research and technology development center in Europe that is multi-sectorial and multi-technology. And we aim to transform the technology into GDP. And we are in the middle of all the sector, the research sector, between the basic research, between universities, in the applied research, and very close to the technology development and the proximity to the market, collaborating close with companies. And we are around 1,500 people, more 50% men and women, and with different countries and a lot of PhD. I come from the transport infrastructure, and we aim to create connection between to bring closer the future. And as has been mentioned before, we aim to measure, predict, and decide for safer and more economic infrastructure. It has been mentioned before by Rafael and Sergio that this was something that we wanted to bring to the proposal when preparing the FORESEE project, that we would like to make infrastructure and economically sustainable, giving them intelligence, optimizing their performance, understanding their useful life through highly technological solutions that make it easy to design. And this is something that we believe that we are doing in the FORESEE project, and when exchanging information with the other projects here today, that we are working to achieve this. Regarding specifically the FORESEE project, as mentioned before, we are developing some cost-effective and reliable tools to improve the resilience of transport infrastructures that are aimed to control, to reduce the magnitude and duration of these disrupting events. Where we are developing new technologies, methodologies that have been, some of them have already mentioned it, but we are working with resilient schemes and how to measure the improvement of the ability to anticipate, absorb, adapt, or recover from potential disruptive event. And when we are talking about disruptive event, we are talking about the natural events that could be the landslides, earthquakes, or the cascade effects linked to them, but also to these man-made events that could be the accidents, the fires, or also that have been mentioned before, the cyber attacks that is not a well understood hazard right now, or in the infrastructure, in transport infrastructure sector. And we are going to validate them next year in 6 case studies, in Italy, 2 in Italy, 2 in Spain, 1 in Germany, and another one in Portugal that I will explain later. But all of them, each one of them has different hazards, and we will validate different things in each one. So all these solutions, outputs, and tools will develop an harmonized resilience assessment methodology, and will be integrated in one single toolkit. And we are thinking on how to support the infrastructure managers in the short, medium, and long term with a whole, let's say, the systemic perspective. By updating the available methodologies, developing new situational aware systems, using GIS, beams, satellite technologies, new technologies regarding pavements, slope stabilization system, new drainages, or engineering of links, but also developing new guidelines for the adaptation of extreme events, defining new plans or adapting the plans to include the resilience concepts for the design, construction, operation, and also for the contingency plans, and also collaborating with pre-standardization activities that are very important to include for future the construction projects the concepts of the resilience from the very beginning, and to support all the whole life cycle of the infrastructure. The FORESEE project is formed by 18 partners in the consortium from all over Europe, Italy, Germany, Portugal, Spain, also UK. And I want also to show you a video that this morning we have checked that I'm afraid that you are not going to hear the sound, but it summarizes quite well what we are doing in the FORESEE project. So back here, I stopped the video. Angelica has just said that the video is going to be available soon in the chat. My colleague Jose is here connected and will share the link. So any doubt about the video, please, Jose, just include the link. Regarding the project, we are just facing the last part of the project, and we are thinking more now in the integration of the different results and outputs, progressing in the development of the toolkit itself, on how to integrate all the different tools inside this, and also on how to validate those results in real case studies. And this is something that we are planning to do in the, let's say, in the second half of the 2021. We are now planning on how to do and how to match everything to be able to do that. But almost we are facing now from here to the end of this year, 2020, almost all the results are almost finished. So will be available, and we are going to work on how to integrate and different parts of the project. Regarding this, the result, the current status of the project, we have already developed some guidelines to measure the resilience and service in infrastructures and to set the target values. Examples and a tool on how the resilience consideration can be incorporated into the infrastructure access management practice. Also, this tool has been developed to develop the hotspot mapping or the impact ranking and so on, and also a stochastic new flooding methodology to characterize them in a more efficient way. Some of the documents that the outputs of the project are public and are in the website. I invite you to participate, and if you link, then in these slides are included the links, and in our website you will find them very easily. Very soon you will be, the project will produce results regarding the slope failure prediction tool to modelize the pore pressure within the soil and predict how it will change and how predictive the slope is going to fail. Another tool, a satellite tool to structural health monitoring and 3D visualization and BIM to the visualization of failure points in a structure. New sustainable drainage system on how to integrate them into a construction project and the strategies to adapt the different infrastructures. GIS tool for the generation of SEC maps using synthetic accelegrams, algorithms on how to determine the optimal restoration intervention after a disrupting event has occurred, which is the optimal path to follow to recover as soon as possible in a less expensive way the service expected, and also some structural health monitoring algorithms to know the structural behavior and to predict the maintenance that this should be done to this to the different structure. And during the next month, more results are coming regarding new permanent asphalts, new stabilization and the slope stabilization system, a traffic model to evaluate any type of resilient flexible backup plans on how to plan rerouting and mode change, but also during the emergency condition, a decision support model to plan how to manage the situation. How to a framework to aggregate data, and also we are developing new resilience schemes and strategic plans in the design, the construction, and the operational and the contingency plans. And we are working close with the standardization bodies regarding the resilience integration. That is something that is missing or is not well included in the different standards used by the sector. So we are developing and working with them. I don't want to conclude my presentation just mentioning that we have inside the project we have organized a stakeholder reference group with more than 130 people from almost 60 organizations and 14 countries. That the chairman is Jesus Rodriguez. Is well known in the standardization bodies. And we try to organize different workshops regarding the results, webinar, roundtables, and document review, depending on the availability of the experts that are participating there. They are from outside the project, and we're planning more interactions. If we are looking to increase the presence of more people, more experts from different sectors and different organizations. So if you are anyhow interested in this resilience and in this kind of activities, please just contact us. That's all from my side. I would like to know that if I have been on time, and just this is the social media and the contact details that you can use to contact the project and our partners. And we will be happy to answer any question about this.
Thank you very much, Iñaki. Thank you for this presentation. The next speaker is Kostas Buklas, who will be talking about the RESIST project. Kostas, I make you the presenter.
All right, so you can see me, right?
No.
I can see myself.
Okay, just a minute.
You have to make presenter the other account so you can see the camera.
Okay, so not the first one. Okay.
So, okay, so I can share my screen now.
Yes.
Okay.
Yeah.
Right. So I'm going to be talking about RESIST. I will try to talk a bit more about the risk module of RESIST as well, since it's one of the latest developed modules, and we started already testing it. Starting by presenting our consortium, we have 7 partners and 2 infrastructure users across Europe and Israel. For a short overview of the project, we have done great achievements in the field of transportation, in bridges and tunnels, but are susceptible to extreme events that can jeopardize human lives, like natural causes, earthquakes, flooding and high winds, physical causes, man-made and cyber attacks. The objectives of RESIST is to protect the users and ensure seamless mobility, to prevent, predict and increase resilience, and to react and provide optimal information to the end users and the users of the highways. I will talk about our system and how it has been shaping up. We're going to be using one of the innovations that we're doing, that we'll be able to use drones in order to mount sensors that are vibration modules, and we'll be using laser systems and radars in order to on the drones and on the ground. The whole idea is that the periodic collection of data is costly, time consuming, and in case of damaged infrastructures, it can be dangerous in the life of the workers. The AirPass systems are going to be using, they're going to be used in order to mount the new sensors and collect data from the sensors attached to the drone. That's going to be both visual, as I mentioned below, collect 2D images and create 3D images of the structures, but contact inspection sensors as well. We're going to be using the RedCom node in order to assure that we have secure data communications, which the RedCom node is a mobile cabin moved to critical infrastructures, and it can take over the whole communication network of an area. It has a lot of satellite. It has a lot of communication channels like satellite, UHF, VHF, LTE, and all the standard communication channels. And of course, we're going to have a ground control station to integrate with the drone systems and its components. We're going to have situation awareness decision using data collected from sensors, collected images, extended vulnerability assessment models based on civil, mechanical, material, engineering models, and psychological and behavioral factors. We are developing a system for motion detection, and that will be able to give personalized information to the users of the highway depending on their psychological and behavioral state. Strategies for mobility continuity, which are going to be multimodal, and they will take into account cost as well, and strategies for risk assessment and management. Of course, we're going to cover the whole system with a cross-layer cybersecurity system that will cover not only the network part of the system, but the field devices, including the drones as well. The resist platform can in real time be aware of the situation and recommend actions to avoid and minimize the impact, as well as propose measures to increase the resilience in the future through the risk management and assessment module. Finally, we are developing a mobile app which is going to be used in order to disseminate information about an event to the users of the highway, and also it will be able to disseminate information from social media. Now I'm going to talk about our risk assessment and management module. The objective that we had on this module was to develop a methodology and a software tool for risk assessment and management for the critical land transport structures under extreme events, in order to optimize the selection and prevent and reactive adaptation measures. In general, what the system was what is supposed to do is that it collects information from all the other modules, being measurements, being the mobility continuity, traffic control, and it makes an analysis of the event in order to notify the end user, the manager of the infrastructure, on what is the state and what is going to be the future state of the structure. We implement the above in the case of a highway, bridges, and tunnels, which we consider being the most critical infrastructure on a highway, and we're going to demonstrate the above in 3 case studies that I'm going to mention later. Excuse me. This is the resist risk assessment methodology. Integrates the models of hazards, damage, and consequence in a unified analysis procedure. Its final form, the entire procedure is based on a sequence of 4 models: the hazard model, the physical vulnerability model, the damage and functionality model, and the environmental and socioeconomical model. Over here, you can see that we were doing a risk assessment without the protection measures. Then we follow with a risk assessment with adaptation measures. The two are joined to give us the risk reduction and the cost effectiveness. In case that if a measure is deemed to be not cost effective, it's not implemented. The hazards under study are earthquakes that including the ones that are more severe than in codes, so we can ensure that that we can assume that there is a serious damage on the structure. Explosions, fires in tunnels, landslides due to earthquakes or floods, structurally affecting bridges and tunnels, scouring of the riverbed in floods causing settlement of bridge piers, and of course cyber attacks. The above in tandem with adverse climatic conditions that accelerate material degradation. And here you can see the probability of structural failure as we designed it in our risk module. Needs to be pointed that in order to assess the likelihood of man-made threats such as explosions, cyber attacks, without any proto statistical data, it's very difficult because these acts are intelligent and deliberate. Alternatively, extremely sophisticated attacks are only able to be accomplished by a handful of entities and can be considered to have a medium probabilistic occurrence. So, in our case, we just assume that there was a case. The social, economic, and environmental consequences is we have a hazard that affected the highway and caused some kind of damage. We are considering that we had, unfortunately, loss of life or injuries, environmental loss and economic loss, and we're checking for direct and indirect effects. I will just continue with some of our other innovations. I will be very quick. Aerial robots for the inspection and mounting of sensors, ultrasonic sensors suitable for the air pass, computer vision system suitable for the air pass, secure and resilient communication system, a cross-layer cybersecurity platform that is already developed and actually it's under test, mobility continuity for passengers, which as well is developed and is under testing, and the risk assessment management system, which is our last developed module, which is now already tested in 2 scenarios for the Egnatia T9 bridge. as I said, the validation is we have the bridge, the T9 bridge in the metro area in northern Greece that we are using for our main validation scenarios, and then we have the viaduct, the 8th Milliard viaduct in Italy that we're going to recreating simulations of the scenarios that we run in the bridge above in T9, and then the St. Petronila tunnel, which is mostly used in order to check the drone in a GPS denied environment. That's all, and thank you very much.
Thank you very much, Kostas. Thank you for this presentation regarding the RESIST project. The last presentation will be given by Philipp Krabosinski for the Panoptis project. So Philipp, just a minute, and you'll be able to give it. Philipp, we can't hear you.
Okay, can you hear me now?
Yes.
Okay, thanks, Wal. So good morning, everybody. I'm Philipp Krabosinski from Airbus Defence and Space, sorry. So next slide, please. So I'm only the coordinator of the consortium, so I will present you the consortium so you can understand the content of the project. So we have National Technical University of Athens dealing with computer visions, and from one side, and from the study of the infrastructure and the vulnerability of infrastructure. We have two very good end users for the road infrastructure monitoring. The first one is Acciona, engineering area, but they can involve also construction. They manage a motorway from Madrid to Guadalajara, and they are dealing with the hazards that can be found in Spain. And the other end user is Egnatia Odos. So they are responsible for the management of a motorway in the north of Greece, with similar hazards than Acciona, but also additional one, like earthquakes and landslides that are frequent in this area. Acciona is extremely active in the project and make the bridge between the user requirements and the engineering of the system. And Egnatia Odos, they have very operational concern, and they want to have a lot of new technology. So both of them have been involved in previous projects, so they can bring also the feedback from the previous project. Future Intelligence is an SME from Greece building the middleware. So it means that we will collect all the information on a secure cloud, and all this information will be accessible by any end user through the middleware. The University of Twente in the Netherlands is bringing the remote sensing part through the UAVs. IFSTAR, now University of Gustave Eiffel, of course, are working every day on the roads and vulnerability, so they are completely expert in every domain of the road infrastructure monitoring. After, we have a team from Finnish Meteorological Institute and Aristoteles University of Thessaloniki. They are experts in the domain of assessing the risk, especially the natural risk. So like the risk linked to the wind, linked to flood and other ones, they have a strong methodology and a large experience. Sophistic ELAS are bringing the simulation so we can play scenarios just to check the reaction of the road infrastructure. C4C Controls from UK is bringing the information management system, the command and control system in order to react to the event. The HTRAP, which is an analysis of what happens, and the decision support system. Hydrometeorological innovative solution from Spain, maybe I should say Catalonia. So they have also a long experience in the prevision and management of situations, of crisis situations. And finally, we have a confederation of organization in road transport enforcement in order to disseminate all what we are doing in the project. So next one, please. So these are all the project objectives very quickly. So as we consider that the road infrastructure is important for a lot of end users, we are building a distributed and standardized system. We acknowledge that most of the active actions will be done by the manager or the owner of the system, but the system needs to be also useful for civil protection, for the cops and so on. Any organization that you can find that is using the road infrastructure and dealing with the crisis in the road infrastructure. So quantification of climatic, hydrological and atmospheric stressors on a very scientific domain, multi-hazard domain modeling, development of forecasting module. That means compared to what we have for the moment, this module will provide risk assessment in very small steps, I mean less than 1 kilometer. So that means that risk can be assessed at very local level without a need to put the whole area under alert. The structure and geonetical safety risk improve multi-sensor observation. So it's a fusion of local sensors in situ, satellites, and also UAVs. HRAP, I told, and the other one I told about this. So finally, next one, please. So we have a lot of components in the system. I will not describe it, but that means that we are starting from TRL 4, more or less, or 5, and we want to reach TRL 6 or 7 because we are in a research innovation action. So basically, we have 3 dimensions in this project. We have conceived the project as a holistic approach to a system that could be purchased by the end users. So the center of the system is through the information management system, the command and control capabilities, and the assessment and decision support system. This system is designed to be implemented in centers, so local centers, regional centers, or national centers, so as to give clear visibility to the manager of the infrastructure of what's happening. This picture can be distributed to all the other end users with right to know or right to intervene in it. So we give also the capability to the other end users to add reporting reports and information on the system. The system can be adapted to different organizations, so it can be quite centralized for some end user or very local for other end user. On the 2 end users that we have a local management in Spain, a very central management in Spain, but in Greece is very local. So we have built this system as an industrial product. The main parts, the system of the information system and all the sensors and so on, are of course under the responsibility of the monitoring agency. But the other parts might not be fully integrated in the system. I'm talking about the prediction, about vulnerabilities and so on. It's not the job of the road infrastructure manager to predict the risk, natural risk or whatever. So it's included as a service that is accessible in this and adapted for the system. Same for vulnerability. What is important in Panoptis is the system is highly flexible, so it can be used in day-to-day monitoring. So in this case, there's no satellite and no UAV most of the time. We can gather all the information through all the local sensors and meteorological stations. And the other way of using it is on inspection. It means that on a routine base, we can prepare inspection of elements. And finally, the third way we can use the system is on reaction to an event. So in this case, we can use the mobile sensors and we can reinforce the system with a lot of capabilities in order to have a fast assessment of the situation and to react on the circulation plan. Next one. So the pillars of the project is to have a very detailed modeling about the hazards. We have a real-time or near real-time assessment of the security health. We have geotechnical and structure simulation tools. So like this, we can play with the vulnerability of the elements. So a toolkit for the geostructure. Computer vision techniques, but we will avoid redoing what has been done in our previous project on bridges and tunnel assessment. So we can adapt the computer vision to what we want to detect, but Panoptis will mainly focus on large events and not the detection of cracks or micro events. Of course, with this, we can do a quick assessment of the situation, sorry. The forecasting of the weather impact. We have microclimate capabilities, so that means that we have a detailed situation and prediction of situation on every spot, and the resilience assessment platform that we developed as a deep learning technology taking into account the experience from the end user. And all this finishes on the display of some kind of common operational picture that can be distributed to all the end users. In incident management system, that is how to deal with any type of crisis, and gives a lot of help in order to organize this. And finally, a decision support system on what should be done. Next one. So the ambition is the effective management of the road in case of natural or man-made disaster, but also providing a day-to-day system to manage and monitor the infrastructure. We have a lot of modeling tools and simulators in order to predict what could happen. We have a lot of tools that are dedicated to the situation awareness and operation. And we include the capability to have some remote sensing through unmanned platform like UAVs and satellites in order to limit or to avoid having to send people with cars and so on. So I think I will stop this because I'm already too long. So if there are any questions about Panoptis, I can answer.
Thank you very much. Thank you very much, Philipp. That brings us to the end of the first session. Of course, we have a time of questions and answers now. Immediately after this, I already see one question here. Immediately after, I will kindly ask that we put on our cameras just to have screenshots for our dissemination activities. So if you don't mind to do that, we can do that later. But first and foremost, I would just like to read a question here. Just a minute. Just give me 1 minute to do that. Okay, I have a question here. It said, my question to presenters who made projects overview. In some cases, the projects consider a use of 3D models of infrastructure or BIM of asset. Do you mean a digital twin concept? In Israel, we think about BIM as application for desking stage during the construction. The model has changes. These changes turn 3D model to to asset which fits better the concept of digital twin. So I'm just reading it, and anyone would like to answer this question? Or Edward, maybe you would like to ask the question directly.
Hey, Wally, yeah, you asked it correctly. If needs more clarification, I would like to.
If you don't mind, I can answer for resist. In the case of resist, we are using. Okay, I'm muted. We are using point clouds, and on those point clouds, we superimpose any kinds of damage we found, cracks, deformities on the user interface.
Similar from Safeway, we are also adopting open standards for the creation of BIM models. And in this sense, we are considering or we are building our models based on the cloud data collected by mobile mapping system. And also georeference all the artifacts that are related for the monitoring of the infrastructure, even though we believe that some research is still needed in order to integrate fully all the components that could be required in a twin of the infrastructure. As for the moment, for example, in Safeway, we are just focused on geometry and damages that are being found, but it's not a full integration yet with other technologies like IoT or fiber optics, as this is a research which is actually ongoing.
Thank you, Belen.
Yeah, regarding FORESEE, the BIM technology is not a core activity, but we are merging the BIM technologies with the satellite monitoring, in which depending if, and we would like to analyze if it could be integrated also with sensor data, in which depending of the behavior of the structure, well, with information from the satellite or the sensor, and depending of the stream values of the deformation of movements, this 3D model will set, let's say, red, green, orange alarms, something like that, and visualize in a 3D way all the information. Just summarizing a lot the concepts.
For Panoptis, we consider 3D modeling as a prerequisite for the management of the infrastructure. You know that 3D modeling technologies are not really innovative. I mean, they are here, so we can use it very easily. But first, we need to model the network in order to manage the infrastructure. So it's one type of 3D modeling. The second type of 3D modeling is in order to navigate the UAVs and flying platforms. So in this, we need to have a cloud of points in order to define the trajectory of the UAV, which will be fully automated. And finally, we use the 3D modeling in order to detect some movement in the slopes around the motorways. In some also the movements that we have. So in this case, we have a 3D modeling using photogrammetry, but it's not so much innovation because the end user is doing it doing it by themselves with one UAV and with mobile platform that means a truck in order to model this in 3D. We are using some kind of digital twins in order to make the scenarios that are simulated, and then in order to test the simulation and just see how the infrastructure reacts.
Good. Thank you very much for these answers. I would now like us to go to session 2, but just as I said a few minutes ago, if you don't mind that you all open your camera just for 10-15 seconds, and then we will just take a picture, and then you can put off your cameras. 5 more seconds and we'll do that if you don't mind.
Limit of webcams.
Okay, thank you. Now we'll go to the next session. That's the panel discussion, which will be moderated by my colleague Terry Gauger. Terry, over to you. Terry, we can't hear you. Terry, we can't hear you. So just give us a few seconds. I think we have some technical problems.
Okay. Good morning, everyone. Can you hear me now?
Yes. Yes, yeah. yes, we can. Yeah.
Good. Sorry. So good morning, everyone, and thank you for attending this workshop we have had in the morning in the first part. Very interesting insight into innovation development in the pipeline, and thanks to the Commission for providing funding on these 4 very appealing projects, which will definitely bring some solutions in the very near future. Well, to follow up on this first part, we have in mind to invite a few other speakers and experts, well, to debate a bit and to bring some insight on how to minimize the impact of these natural and man-made extreme events on seamless transport operation. And we will have indeed Laura Tordera, who is the head of R&D and Innovation Department at Ferrovial. We will have also Mr. Federico Di Gennaro from ISCAT, is the head of strategic projects. We'll have as well Mr. Rade Ashdin, who is the founder and president of Infrastructure Management Consultant based in Switzerland, and also a professor of civil engineering. We'll have Mr. Vicente Arino Peñalver, who is the head of infrastructure maintenance at Acciona. And we will have as well Mr. Jurgen Krieger, who was our keynote speaker today from BAST. So, well, before we start the roundtable by itself, I understand that you would like to bring
Terry, we can't hear you. It seems the...
Okay, I don't understand. It disconnects all the time. So
yes,
now
yes,
I just...
It's okay now.
I want to invite now to start with Mrs. Laura Tordera to bring her first main remark before we go deeper in some specific issues. So Laura, the floor is yours, and I understand, Wally, you will put the slide.
Yes, I'll do that in a minute.
Okay. Can you hear me?
Yes, but there's an echo.
Okay, can you hear me now without the echo?
Yes, it's okay, good.
Okay, and can you see me now? Okay, my name is Laura Tordera. I am the Global Head of Innovation in Ferrovial Construction. Ferrovial is a Spanish multinational company involved in the design, construction, financing, operation and maintenance of transport infrastructure and urban services. And we are here because we want to talk about resilience. Resilience is a critical factor for us as a group, and more particularly in Ferrovial Construction, the construction branch of the group. Due to the relevance resilience has for us, we are actually involved in two of the calls projects, FORESEE and SAFEWAY, presented previously by Iñaki and Belén. The good practices and strategies that drive the improvement of the resilience of the European transport network are, first one, identification and understanding of risk factors, because risks need to be identified and understood over the full lifespan of the infrastructure. It's necessary to identify them and to have a deep understanding of the likely frequency and magnitude of risk and how they are likely to change in the future. It's important to try to understand what the possible future changes might be. This requires an understanding of climate and disaster risk and an understanding of current weather patterns. The second one would be updating natural hazards mapping. Hazards maps are there already, but they need to be adapted. Some of them might still consider 100 years occurrence cycles. The third one, adaptation measures, new materials, designs, and retrofitting solutions. The use of new materials, techniques, and designs for construction is needed in order to adapt our infrastructure to the new existing conditions. Nowadays, the transport infrastructure begins to suffer the effect of weather changes and to not fulfill the technical and safety criteria for which they were designed. The fourth is infrastructure structural health monitoring. Structural health monitoring is extremely important in order to evaluate the health of a structure by assessing the level of deterioration and remaining service life of civil infrastructure system. Data-driven methods in infrastructure health monitoring are gaining popularity due to the recent technological advancement in sensor, as well as high-speed internet and cloud-based computation. Embedded sensor and remote sensing are other options. And the last one, sharing data and knowledge. Worldwide, there is a rapidly growing amount of knowledge and data on infrastructure health monitoring system at different stages of development. Sharing this data would serve as possibly to join forces and build collaboration for further research on infrastructure resilience. This is it's a general overview of these strategies and practices that we are studying now in our projects.
Thank you, Laura, to share at first these good practices and strategies. Well, I'd like now to invite Mr. Federico Di Gennaro from ISCAT. Well, please, now the floor is yours, just to brief us on your main statements. We can't hear you, Federico.
Now can you hear me? Hello?
Yes, we can.
Yes.
Okay, thanks. Sorry for this inconvenience. So, my name is Federico Di Gennaro, Head of Strategic Projects of ISCAT Servizi, the consulting engineering company of ISCAT, the Italian Association of Toll Motorways. If you can go to the next, please. I will go directly to the point. Next, please. Let's go to the content. Next, please. And the next one. Okay. So first of all, I would like to warmly say thank you to the European Commission, which gave to these four important consortia the possibility to work for contributing in boosting the resilience of the European infrastructure, to Ferl as organizer and to Thierry Gauget as moderator. First of all, I have to say that we have to consider extreme events as normal events. Our climate is changing and we should rapidly adapt to new conditions and to unpredictable phenomena. To do so, we should embrace the concept of resilience at every level, including the decision-making level, because it is clear that we cannot develop the most efficient technology, the most efficient procedure, if we are not able to push also our decision makers, our politicians, in changing the regulatory framework in order to facilitate a better adoption, a better response in preparation and mitigation phases. But also, we should consider not only climate-related events, because as we saw, the pandemic dramatically affected our business. To give you some numbers, consider that on the ice-cut toll roads, we had a minus 85% of light vehicles traffic if compared to the previous year, April this year versus April of the previous year. The pandemic had and will have a huge impact on the revenues and consequently on the financial capacity to improve the maintenance. On that respect, considering climate and pandemic effects, we are also working to improve our emergency management plan, including the so-called black swan scenarios. Next, please. What are the main challenges in our opinion? There are several types of tasks that we can afford. We are improving our technological and organizational response by adding new tools to the operation and maintenance phases, but we also have to consider other factors that are outside our domain. The first one is the time misalignment, because the political cycle are not in line with the long payback period of adopting resilience measures. Another important point is to involve and engage all the different types of stakeholders, not only road operator, of course, or engineering firm. Another topic is related to the calculation of externalities of adopting resilience measures. We have to extend the potential benefits not only to physical assets, but also to the communities and to any kind of subject or entities that can receive a direct or indirect benefit from the adoption of resilience intervention. The last point, in our view, the most important one, is related to funding, because we should look for new instruments to overcome the difficulties of raising low-cost capital. And there are a lot of new financial instruments to fund resilience infrastructure interventions that can be used. And I will be glad to give you more information by email or later on during the panel discussion. Thanks.
Thank you very much, Federico. Rajay Ashdin, well, as a consultant, what would be your main opening statement?
Well, do you hear me first of all? And good morning to everybody. You do hear me, right? Okay.
Yes.
Apart from the fact that my name is actually Rade Haydin, I would also like to maybe give some input to this panel discussion. And I think I submitted some slides, but maybe and you can skip the first one and go straight to the second one. And if the title of this panel discussion is how to minimize the impact, and of course, can you put it in the presentation mode, please? Appreciate that. So you can click now. I have to tell you to click. So the how to minimize the impact of both natural and maybe extreme events on seamless transfer operation. Now, the question is where to attack, because the problem of minimizing impact to resilience can be tackled in different ways. And one of the possibilities, of course, to try to reduce the threat itself. And then if that is not possible, maybe we should increase the resistance of our infrastructure in order to prevent that. Or maybe if that's not possible, you can click again. Maybe we could go and reduce the consequences. And maybe we can, if that's not possible, then we can go to the recovery, having contingency plannings, maybe short-term planning, restoration activities, until we finally, next click please, until we can have restored service. Now, this is not a trivial task to figure out where to attack, because things are different, of course, have different costs entangled to the different measures that you can put on these different levels. But one of the main points that we have, when we go to the next slide, is that, next slide, please, that if we want to have a good practice strategies, I want to be very simple on that one. What would be the most efficient measures to improve resilience? Well, in my personal view, we need a reliable data-driven insight into endangering scenarios. We need somehow that everything happens in the head, essentially. We need to have a little bit of a paranoid view to what can happen and how to prevent, especially cascading events. Now, this means that we have to know really what is going on in infrastructure. And currently, we have a lot of data which are not structured and not used well. I mean, if you look, we have designed all this infrastructure. We have a lot of paper data, some restored in archives, and we are not using that in a proper way. So apart from the target-oriented diagnostic, which is supported by inspection monitoring, we need to somehow use this knowledge that is already there about, for example, load carrying capacity, material property, geology, etc. So these two things together, the clear insight, the good insight in our infrastructure, together with the diagnostic and monitoring, these two things together can move us further with regard to the minimizing the impact of resilience. And yes, there are sophisticated methods, but we have also things that are not so sophisticated and we are not using it currently as we should do so. And of course, the contingency already met here, both organizational and financial, for planning for recovery intervention can improve, of course, resilience. When I'm talking about financial, I'm also talking maybe the ideas of insuring and reinsuring some of these hazards. We also saw especially in Switzerland with the pandemic, that helped quite a bit, and this can be also maybe used in the infrastructure. Now, I think my 3 minutes are over, and I will give back to you, Thierry. Thank you very much.
Thank you, Ali. Well, last, I would also like to invite Vicente Ariño Peñalver, just to also do the same and bring your main statement.
Hello, can you hear me?
Yes, we can.
Okay, I will try to activate the camera.
Yes, please.
It's not working. Camera. Now, can you see me now?
We cannot yet, but I propose anyway, you can start anyway speaking, doesn't matter.
It doesn't matter, so I will try last time.
Yeah.
Now, I think it's working.
Yes, it is. Yeah, thank you.
Okay, as you see at this slide, I'm the head of Acciona Infrastructure Maintenance Division of Acciona, which is an international construction company that runs its business alongside the whole world. So if you can move to the next slide, please. The previous speaker has already spoken regarding the risk that we face and we are already facing. So I will pass to the next aspect, that are the tools that, from the point of view of O&M, where I base my knowledge, is very important for us. So during the Panoptis project, my division has been working very closely to this project to implement all the tools, sensors, and to try to see how does it work. So what we have been trying to build is a good management systems, because GIS has been already working in this business for more than 25 years, and they are still developing. So we try to develop a holistic integration holistic system that allow us to integrate the resilience management information into those systems. So we are on the progress to do that, and when we finalize that task, we will be able to start having good decision, not only based in our experience, based in what we already see using this technology. Can you pass to the next slide, please? So what we want, what's our aim? Our aim is the digitalization of all the road O&M services to operate them in a most effective way, because in a context of budget reduction that we all suffer by the politician natures, we need to use our tools and our research in the best way in order to be able to manage them very efficiently. What we want to get? We want to get that the users that are the one that has to suffer all these disruptions in the services don't have them. So by managing all those tools, we will be able to deliver the best service. From our point of view, and after working closely to Panoptis, using weather stations, weather information, even mobile weather stations, and other type of sensors, we are starting to see the benefit in the main, despite Spain, we have very terrible problems in winter with the snow, management, the winter maintenance operation, because we want to try to reduce the salt and brine spread. And by using this technology, we will be able to reduce it. And another very important thing for us is reduce the work environment, the safety, and reduce the cost through those tools in maintenance, and reduce the cost of operating the equipment that we already have. And so far, what I haven't seen from what we are developing, we are just obtaining the first benefit of those tools. So we expect in the future we will be able to run in a most efficient way our business of O&M for sure. So that's all I want to say. If you have any question afterward, I can come back.
Thank you very much, Vincente. Thank you all for bringing this very important statement, which definitely complete very well the input we had in the first part of the workshop. Well, I would like to continue for the last 15 minutes on some specific issues. And well, maybe at first, Laura, I would like to ask you the following. We heard quite much this morning about resilience, very much turned about infrastructure. But well, as everybody knows, resilience is not just about infrastructure. It's also about individuals, communities, and institutions. Well, from your point of view as a construction company, how do you see this? And especially in light of the COVID pandemic that we have all faced, are there any lessons learned for infrastructure that we can collect from the different countries where it's been relatively successfully dealt with? Could you please enlighten us on that? What's your view on it?
Okay. Yes, can you hear me?
Yes, we can.
Okay, thank you so much. Yes, this is really important, the concept of community. Transport systems are a fundamental part of our communities, our modern social and economic infrastructure. Transport systems enable the free movement of people, goods and services within and among Europe, enabling the generation of economic wealth. Unfortunately, this freedom is now temporarily limited because of the COVID pandemic. And although we are going through very difficult times, there are some lessons that we can learn from the pandemic management. For example, we have the case of South Korea, and now it's a success story. South Korea became the first country to surpass China in the number of newly infected people with coronavirus at the end of February. The epidemic reached an alarming peak at the end of February, with almost 1,000 cases reported in a single day. But the trend began to change from that moment. At first, the authorities' management was made difficult, but this did not prevent them from deploying a successful strategy to significantly reduce the spread of COVID-19. And above all, to reduce its lethality. We have, or there are 4 main reasons for this success story in South Korea that we can learn in the infrastructure world. The first one is the use of lessons learned from past catastrophes. The experience in this situation is important to avoid new problems in the pandemic situation. It's important to have a rapid response. It's important to a successful public and private partnership, because it could be a key success for infrastructure. The knowledge and the data sharing should be essential to unite efforts to build and maintain resilient infrastructure. PPP are not new, but they are becoming more and more important in our sector. And last but not least, transparency and trust. This is very important. The lessons learned that we can learn here is that sharing knowledge and data and work united in the same direction could be very important to start a new life.
Yeah, thank you very much for highlighting this open data and also this need to be closer between public and private on that matter. Well, Mr. Krieger, Jurgen, you presented in your keynote this cycle that you judge very important to being, let's say, at the heart of the resilience, with the 4 phases: preparedness, response, mitigation, and recovery. Well, in broad terms, looking at the state of the European transport infrastructure, which is not necessarily at best, what would be your main areas where you really recommend to lay more emphasis, and why?
Hope you can hear me well. So yeah, thank you for this question. It's a tough one. So what is more important? All of them are important. First of all, I think we have to distinguish between critical infrastructure, this was mentioned today, and let's say the other infrastructure. I don't say it's not critical. With critical infrastructure, we often talk about hardening. This is a term very often used. Hardening refers to protection and mitigation. So that's true for us. We could, for example, design our bridges or tunnels or whatever for higher temperatures, for more wind. But the question is, can we really, or do we want to design against, or better to say, for everything? I'm not sure if this is the right approach. Therefore, protection is an element, probably not the only element that is important to owners and operators of transport infrastructure. So I think what owners and operators should do and need to do, and I completely agree what Rada Haydin said. We have a lot of information. All the operators have this information. So we should look at our data that we have available, object-specific, construction-related topics, but then also, and this is not done very often, we should look on the criticality of specific pieces of road or specific elements. So, and look at the impact of availability or unavailability on our for our road network, for our operation. So this refers to preparedness. I'm not sure if all the operators are really prepared for this. And then looking at the economic impact. So we, of course, we have the direct costs like replace a bridge, repair a tunnel after an incident, but we also have users' cost, the cost for the user. And this is CO, this is additional travel time, and so on. So we have analyzed a couple of examples for highway bridges that we lost. And what we see is that within a short amount of time, the indirect costs, which means the user costs, are a magnitude or more higher than the direct costs. So I think what we need would be indicators for resilience. How resilient are we? How critical are our elements on object and of course on network level? And then we should look at approaches for a quick return. This is also a design issue, especially for new infrastructure. Emergency response plans I have already mentioned, and of course hazard-specific measures. I mentioned design or upgrade infrastructure for certain hazards. So it's difficult. I cannot say which one is the most important, but I hope I somehow could answer the question. Thank you so far.
Thank you, Jurgen. And I'm sure that all our speakers presenting the operators and managers would be happy to complement that, and especially with regards to the critical aspect or the criticality of the infrastructure. But within the given time we have, I would like more to ask, to take this into account for and Vincente, but also having in mind the budget. And as you all know, we face some budget restriction more and more. So how, how do you envisage tackling resilience with this decreasing budget? Federico, to start, would you like to start with that?
Yes, thank you, Thierry. This is a very good question for an economist. Well, first of all, some background information, because a recent report by the World Bank estimated that the disasters forced some almost 26 million people into poverty, whilst causing more or less $60 billion of economic losses annually. And more than 200 million people per year are affected by this kind of events, such as earthquakes, cyclones, flooding in developing countries. So the equation disasters equal poverty is actual than ever. Disasters also cause significant fiscal and economic shocks to vulnerable countries. For the highest risk countries, the cost of disasters can overwhelm the capacity of governments to respond, and this can amplify the impacts on the lives and livelihoods of people. We are investigating also, thanks to a report we analyzed called the Financial Instruments for Resilient Infrastructure, different innovative tools for financing the resilience intervention. And I will bring you some examples. The first one, it is called Insurance Linked Loan Package, which is basically an infrastructure loan which has a built-in insurance component. Insurance savings through risk reduction offset loan the interest repayments. The second one, it is called Resilience Impact Bond, which is a pay-for-performance contract in which an investor is remunerated based on how well they implement resilience measures according to predefined performance indicators. The third one, it is called a resilience bond, a risk transfer instrument in which risk reduction is reflected in a reduced premium paid by the insured across the term of the bond. And the last one, it is called, it's a type of company, it's called a Resilience Service Company, RESCO, which is a company who bears the initial cost of resilience, and it is repaid on an annual basis using savings on the insurance premium. So in general, there could be many ways to find a financial tool. We are also in our association, we're investigating some of these tools. My recommendation is that it is very, very important to bring the importance of resilience on the table of decision maker, to the politicians, to further promote also a culture of resilience. Otherwise, we are destined to fail. So I really hope that we will overcome this issue.
Thank you very much, Federico. Vincente, would you like to add a couple of things?
Yes, just coming back to the O&M point of view, where I'm expert. In terms of the O&M of the road infrastructure, I see that we should develop a good management plans which contain clear procedures to prevent, mitigate, respond to, and recover from a risk using KPIs, and those plans, in conjunction with the use of new technologies, will result in a comprehensive GIS or BIM for all the length of the road network. And let's call BIM just for special elements, big slopes, bridges, or tunnels. These two aspects together need to be integrated in an MDSS web system to manage all activities and resources related to the operation and maintenance works in infrastructures based in standardized norms. That's very important. This digitalization of the road and O&M works will end to the most effective way to assign limited resources at the right time and in the right place. By doing that, we will reduce efforts, time, with less spare cost. That's my thoughts.
Thank you, Vincente. And what about you, Rade? As a consultant, how do you feel advising on this issue?
Well, I guess I put the main focus of my interest into the providing or finding data that are necessary to give a good consultant services. And in my experience, and we are dealing quite a bit with it, we are trying to structure data in a way that we can use it to first assess risk and also consequences and within the risk, and again the recovery possibilities at the end. So I guess if you want really to do something about resilience, then my best advice would be to take a look into the existing data. And believe me, I have seen that there are quite a lot of them. It's a not very interesting work, though. It's a tedious work to look into the paper archives and to put together data, but there are very valuable information in there that you can use later on. It's not really necessary to do all kind of monitoring inspection techniques. They are very useful once you know what's going on in your infrastructure. But the first step would be definitely to collect the existing data and to find out what the people were thinking back then when they are designing infrastructure. What kind of hazard did they take into account, or what kind of hazard did they forget or didn't consider in their design? So I think the best advice, it's again not very sophisticated work and not very interesting work, but it's nevertheless very useful to take a look into the design documents and also into maybe the monitoring inspection documents from the past. That would be my best advice to them, also the most cost effective, as it turns out to be until now.
Thank you very much. Well, we have understood from this panel discussion, also from the presentation this morning, that resilience is indeed not only a challenging topic, but is getting also a broader topic compared to what was the definition several years ago. It encompasses a number of elements that are critical to manage it in a effective way. That's something we need to do in Europe. We have some possibility to learn also from outside. And just before we end the panel discussion, I would be happy, Mr. Krieger, Jurgen, if you want to just very briefly in 1 minute highlight some key information that we could get maybe from Asia and from the US.
Yes, thank you, Thierry. So I can see that we are running out of time, so I will try to be really brief here. So the US, yes, research is funded in the US on resilience by HCHRP, especially for the roads. So they have a long history. What is different maybe from Europe is that a very, very strong involvement from owners and operators is necessary to have a research funding. This means AASHTO needs to support at least 3 or 4 DOTs in the US have to support a project. This means, or this the result is that research results can then often implemented immediately. And this is on research. Another thing is that research or that the DOTs are working on resilience on a strategic level. I haven't seen this in Europe so much. I talk about roads, so this would be CEDAR. I don't see this, that resilience is a topic on research level, on strategic level for European owners. So this is something I noticed from US. Korea, Thierry, you remember our scanning tour a couple of years ago, and what we saw there is that innovative technologies like big data, smart systems, sensor data, communication between user, vehicles, infrastructure, we found this, and these technologies were more or less rolled out. So they are really innovative and they are quick. And with regard to new technologies, I would say Korea is ahead of us, ahead of Europe. Maybe this is data privacy is an issue in Europe, which we didn't find so much in Korea, but they have rolled out these most of these technologies that have been mentioned today. So this is, I would like to end with this. Thank you.
Thank you very much, Jurgen. Well, here we are ending now our very interesting workshop. Well, can I ask all the panelists to just turn on the camera so that we can give you a round of applause? So I'd like to thank very much once again Laura Tordera, Federico Di Gennaro, Rade Aydin, Vincente Arigno Pernalver, and Jurgen Krieger. So thank you very much. Thank again to all the projects which have been participating to this program this morning. That's not the first time that we try at FERL to bring several projects funded in the same topic. I think it's part of our duty as well to create the complementarity and the synergy between ongoing innovation. And we are very pleased to do this well now virtually. Hopefully there will be a time where we will be again able to meet physically. This is for a near future. Hopefully 2021 will be probably the year of being able to meet physically. But in the meanwhile, thank you very much for this, to discuss this challenging topic of resilience. And as we heard this morning from Rafal, there will also be opportunities to further work on the pipeline progression towards our innovative solutions in Horizon Europe. So we have to be prepared for the call that will open in 2021 and 2022. So thank you very much once again, and have a nice end of the day.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.